In this class, we are going to see about the fundamentals of radiation mechanism about antenna. So we know that the sole responsibility of antenna is the electromagnetic radiation or the reception. So if it is radiation, it is the meaning the transmission, and if it is the capturing, then it is the meaning for reception by the antenna. So whether it is used for transmission and reception or for both, it has to be connected to the circuitry to any station through the transmission line. So the function of antenna depending upon the transmission line at which it is connected, and it depends upon the radiation mechanism of the transmission line. So now in this class we are going to see about the radiation mechanism of different types of transmission lines. So before we go into the categorization of the transmission lines, we should know the basics of radiation. So what is conductor? So any current carrying conductor which passes the current over a large distance with minimum loss is called as a transmission line. So transmission line, it is nothing but the conductor which can be able to pass the current over a long distance without any without the loss or the negligible loss. For example, you can have the simple wire which can connected to the antenna can act as the transmission line. So the transmission line conducting current with uniform velocity or the line being the straight one without any discontinuity with infinite extent cannot able to transmit the power. So the transmission line with the uniform velocity current or the transmission line with the smooth surface without any discontinuity over a long distance cannot able to transmit over a long distance. So for wireless communication, the main function of the antenna is the critical component is antenna, and its main function is to radiate. Yeah, for the good design of antenna, it has to improve the overall performance. For example, we can take the TV reception. The broadcast reception has to be improved with high performance antenna. So the antenna is a system component. It is used to radiate or receive the electromagnetic wave, or it can also be called as electromagnetic transducer, which is used to convert the electrical wave from the electrical wave to electromagnetic wave in transmission mode and the electromagnetic wave to electrical wave in the receiver mode. So in modern communication, the antenna or the directional device has to be used to optimize the transmitted and received signal in some direction while suppressing it in the another direction. So this is the history of antenna. It has been invented from the Maxwell equation in 1873, and it has been prolonged by the Henry Rich Hertz, and he has demonstrated the first wireless electromagnetic system in 1886. So here this is the basic fundamental equation of current. I is equal to Q by T, where it is a ratio of charge flow of charge carriers with respect to the time. So current means it is the flow of charge carrier with respect to the current. Where Q charge, so if you rearrange this equation like that, and if you differentiate that one, you will be getting this equation di by dt is equal to rho 1 into dv by dt, where rho 1 is the linear charge density and v is the velocity. Right, I is the current and t is the time, and here where a is the acceleration of the charge, and this equation L into di by dt, that is equal to L, that is the length of the conductor, and rho 1, it is a linear charge density, and the acceleration of charge. This equation, it is called as the basic relationship between the current and the charge, and it is known as the fundamental equation of the electromagnetic radiation. Now, so that is the basics of radiation. Now, how the radiation can be takes place in the single wire. So as we seen already, there are two conditions for the radiation to be takes place. One is the current has to be oscillated, or the current should not be with the uniform velocity. And if it is a current, it's a steady current with the uniform velocity, means the medium through which the current, steady current passes, it should be having some discontinuity in terms of curving, bending, discontinuous, terminated or truncated manner, right? So the electromagnetic radiation can be produced at the end of the another at the another end of the transmission line along the wire, if these two conditions is any of these two conditions is satisfied. And this is a different way how we can able to produce the discontinuity in the single wire by bending, terminating, by connecting to different length of the wire, by connecting to different diameter of wire, etc. and this is the radiation from the single wire continuation. So since the magnitude of oscillation retardation is not uniform throughout, as a result the broad frequency spectrum has been established. Again, if it is a frequency spectrum, means that the bandwidth depends upon the pulse width. For AC current, there is a single frequency. AC current, there is a single frequency radiation. So the moving charge through curve or bent wire experiences the difference in the velocity, which will produce a centripetal acceleration, which can able to produce the radiation. That is a one mean, that is a change in velocity will produce as a radiation. That is the first point. Second point, for discontinuity, if we introduce the discontinuity in the conductors, then the conductor wire or the conductor which act as the transmission line for the flow of current, impedances changes, and that impedance changes rapidly at a point of discontinuity, which produces the radiation also. This is the basic diagram which explains the difference between the guided and unguided medium. This is a generator or the transmitter. So the signal from this generator will pass through this transmission line up to this point. So up to this point, this is called as a 2D propagation, that is two-dimensional propagation or guided wave propagation, that is called as one TEM wave, that is a transmission line. So here in this point we have produces a tapping, so we have produces a bending in the two-way transmission line in up and down also. That's why it is called as tapped transition. So here after this point, the uniform velocity of the flow of electrons up to this point of the transmission line will be disturbed, and it will be accelerated or deaccelerated depending upon this tapping structure. So this curved lines with the arrows will explains the change in the velocity of the radiation. So here after this tapped transition, here this is a free space propagation, which is called as free space wave radiation in three-dimensional. And here in this place we will be we can understand that the radius of curvature has been increased. So whenever the distance between the load and the transmitter will increases, so there is a large spreading of the electromagnetic wave radiation or the E lines, which is explained by this increased radiation curvature. And this is nothing but the radiation from two wires. If the separation between the conductor is very small, there are two cases in the two-wire transmission. If the separation between the two wires as conductors is very small as compared to the wavelength, then the electromagnetic field on both wires will be in equal magnitude, and it will be very narrow space, and both will get cancelled. So as a result, there is no net radiation. Whenever we introduce as a open or tapping or terminating and any one end of the wires by using any discontinuity, which will increases the separation between the wires, and the magnitude of the flow of current in two wires are not equal, and it is just opposite. So there is a possibility of the non-zero net electric field. So there is no cancellation, which will produces the radiation. So this is the meaning for dipole antenna. So here which is similar to the two-way transmission as we have seen already. So here up to this point there is no change in the velocity of radiation. So after this tapping, so here you see here this is upward direction, this is also the upward direction. So here this is a point where we have the 3D radiation from the dipole antenna, and here this is a current distribution in the thin wire antenna. So the incident and reflected wave combine to produce a, here you will be having, so in two-way transmission line there are the source which is send the current. So the forward direction one way we will be having the current at the each end reflected back with a phase difference of 180 degrees. So we will be having two waves, one in forward direction, the another one is in the reverse direction. So whenever the incident and reflected wave combine to each other, the another wave is produced, that is called as standing wave. So if the separation of the line is very small, means there will not be any radiation, as we said already. If the open-end region is bent by 90 degree or any other degree, the current in the two wires will not get cancelled. So resultant non-zero field will produces the radiation. So that is the here this is the forward wave and this is the reverse wave. So whenever we have the intersection between these two waves, we will be having the standing wave creations, right? So in this manner, the two-way thin wire antenna has been used to create the radiation. Thank you.